The live streaming URL is on the, if you go to the share option, it's this one here.
It's changed to live on YouTube now.
It's changed to live on YouTube.
Stream.
Okay, cool.
It's working.
It's working. Okay, I'm not going to touch with it anymore. I'm not going to mess with it. I'm going to assume it's fine. Thank you, everybody, for being extremely patient with me.
Oh,
This will be good enough for now.
I turned it on and heard my own voice, and I turned it off. I was like, no, that's not good. That's not going to fly.
I even had a 30-minute timer going. So let's see, we're about 12 minutes to go. Okay. Cool. Okay, can relax.
Can make yourself a very, very quick cup of tea. Oh no, you've got one.
Yeah, I have my coffee. I have my coffee. How is everybody else doing in lockdown, crazy world?
Yeah, we set up. We've got a big canvas bell tent, like a 4-meter bell tent. We set it up in the garden so we can have like an outside office, sit in the sunshine, just to get some fresh air. Otherwise, you'd be going stir crazy.
Pretty good idea. I would definitely do that if I had a garden.
I'm starting to run out of Netflix.
Is that even possible?
I didn't think so. I think it's getting close though. It's a bit problematic.
Only another 8 weeks to go, maybe? I just want to check because I kicked everyone off earlier. Do we actually have all our speakers here? So Dewald, Amir, Andrei, you guys all here?
Yeah.
Yep.
Okay, I think that was 3 yeses, right?
Cheryl,
Okay, one by one. Dewald, you there?
There are 40 people on the old YouTube URL.
Really? Okay. Cool. So
Maybe you need to post the new URL for them because anybody else couldn't post the URL. It's only you probably.
Yes. So, oops. Unfortunately, I can't do that while maintaining this screen, which I want to do so that everyone knows when we kick off. So I will do that after I hand over to Dewald for the first talk. Sound okay?
Hi. Sorry, Cheryl, I just made it back in.
Oh, cool. Okay, good. I think we have people.
Oh, come on. Come on. Why is it doing this to me?
Just catching up. Anyone else got their beer and pizza ready?
Oh, I forgot the pizza.
That's
Ah,
nice.
and the beer.
It's a good idea. It's a really good idea. Next time up, bring your own pizza and beer. It's not quite the same, I feel.
I might just grab a beer from the fridge while you're saying.
Yeah, go for it.
Does wine and lasagna count?
I'm down for wine and lasagna.
So is it just some form of liquid and Italian food then are the rules?
That would be problematic for me. I mean, no, I've got my coffee. I have my liquid. If we're talking Italian, I'd have to use some of my very precious pasta stockpile.
Of course, yes, the stock pan and the tomatoes as well. Gosh, there's me not thinking. Yeah.
I think I'm actually out of tomatoes as well. This
The tale of woe from you, Cheryl, because earlier not being able to get outside, gosh, everything.
well, we're all getting used to the new normal, huh?
Yeah.
The worst thing that happens is I need to struggle a little bit with Zoom and YouTube settings. I think I'm doing all right.
Yeah.
Yeah, Joseph, I will update the URL after I've done the intro and I can hand over to Dewald so that yeah, so then I can be hands off on that and update everything else. And if you're not on the Slack channel, we do have a Slack channel. You can go to this URL and join there as well. Try clicking it. Suppose I can post it in the chat. That might make it a bit easier to click on. Well, at least copy and paste. Thank you, Tim.
No worries.
What are you at? 2 minutes to go. Cool. Well, I think 5 people just joined up in the last few minutes. It's pretty cool. Thank you for joining.
a tiger has tested positive for COVID-19.
I saw that in Boston Zoo, right?
Bronx Zoo, yeah, New York.
Bronx Zoo. That's I know it's really serious, but I don't know, it's so surreal as well. It's kind of funny.
Apparently, there's also reports of a house cat being symptomatic.
I've heard that cats can catch it, but not dogs. So I guess a tiger's just a big cat.
I read something
It's
about
like-
how cats will get it actually on their fur, and that's how, and they've seen it more of humans to cats and animals rather than the other way around. So because I think they're worried people might start like abandoning pets or something like that. So they've made it very clear it's actually because of like things getting stuck onto their fur rather than them themselves having it.
Fair enough.
I mean, that's just depressing.
Okay, well, we're officially ready to kick off. So thank you very much, everybody who's joining either on Zoom or on YouTube. This is Cloud Native London. So we're a strong, open, diverse developer community around the cloud native platform and technologies in London. It's the first time, obviously, that we're running a virtual meetup. So I appreciate you all for joining. My name is Cheryl. I'm the Director of Ecosystem at the Cloud Native Computing Foundation. You can reach me at Cheryl on Twitter. Cloud Native London also has a Twitter handle, cloudnative_lun. So I wanted to start off by asking a couple of questions about you. So if you've got your phone handy or your laptop or whatever you're on, it'd be great if you could go to this URL, which is just a shortened link. It will redirect you to a service called Poll Everywhere. And then I wanted to ask 3 questions about you and 4 questions about how you're using Cloud Native. So you can start with a nice, easy one. So is this your first time at Cloud Native London? Oh, let's give me a moment. It seems not to have registered that the presentation has started. So let me try this one more time. Oh, the link times out because of GitHub must be down. If I had a moment, I would check if, or maybe someone else can check if GitHub is having issues, because my blog is hosted on github.com.
GitHub status saying is everything's fine.
Okay. No worries. So we can just use the full URL once this loads. Again, let's just give it a minute for the, here we go. So this is the full link, pollev.com/CherylHung278. And then you'll just get a survey. You can get yes and no. No, it's staying pretty close to 50-50. Cool, more yeses than nos at the moment.
Sure.
Cool.
Could you share your screen again?
Oh, are we not sharing?
It stopped like a minute ago.
Okay.
Perfect. We can see it.
Okay, Sorry about that. Okay, I think we're pretty settled. Seems to be about 55% yes and 45% no. So especially welcome to the people for whom this is your first time at Cloud Native London. Okay. Let's go to the next slide. So next question, where are you now? So we've got 3 options: London, the rest of the UK, and then the rest of the world. Oh, this is super cool. I think someone's just landed in the middle of the ocean here. Yeah, this is awesome. I'm really happy to see that there's so many people who are joining from outside London. This can be a good opportunity to reach more people. Cool. Feel like we're slowing down. Yeah, YouTube is a few minutes behind Zoom, so unfortunately it's not gonna be as fast for people who are in YouTube, watching this from YouTube. Okay. So, third question, what is your job title? Or closest approximate? Cool. Anyone who put in other want to share either in the chat, or they can just speak out, like what do you do? Data scientist, cyber risk manager, SRE, analytics, infrastructure, SRE, cloud architect, platform engineer. Yeah, so I picked these names off the latest CNCF survey, the top 6 or so results. So it definitely doesn't cover all of the names. Cool. So apart from other software architect and backend developer, looks like the leading ones. Okay, so now a couple of questions about how you're using cloud native technologies. Wait for this to switch. Okay, if you are running Kubernetes, how many clusters are you running? So I'm talking production clusters, so not dev or test. Pre-production equals pilot, yeah.
This is good numbers.
Okay. Good numbers.
Yeah.
So from what I remember from the CNCF survey, this lines up pretty well as well, that majority of people are running 2 to 5, and then there's a handful of people who are running 50 or more. I think usually either cloud providers or consultancies, something like that. Yeah, very interesting to see the spread. Cool. I think the numbers are settling, so we can go to the next question. I'm not sure if it's Google's Docs being slow or whether it's the polling service being slow.
I think it's the whole internet, to be honest.
Oh, it's the whole internet. Yeah. Okay. So this is like a Reddit upvote. You can add comments and then do upvotes and downvotes. So what is a challenge that you are facing right now and you would love to chat to somebody else? Apart from the pasta and toilet roll and tin tomatoes problem. So it seems like the top one is the Multi-Cluster Management Federation. There's someone who voted for that want to say a sentence or two about why it's a challenge for them? Cloud Native Ingress takes the lead. So anybody want to say a word about it? Okay, I guess people are feeling shy. Okay, I think we have one more question. How to convince CFO to invest? Okay, so definitely seems like multi-cluster. Seems like the biggest challenge. Okay. Oh, so that was in fact the last of the questions. I thought there was one more. If you want to get involved with this, you can go to this URL that has a reminder of how to join the Slack group, get to all the past meetups, speak or sponsor. And talking about sponsorship, so we have a few people on the line representing different companies who sponsor Cloud Native London. So Megan, do you want to start from Technovo?
Sure, I'd love to. Hi everyone, I hope you're looking after yourselves. As Cheryl mentioned, I'm Megan and I'm community advocate at Technovo. Technovo is a digital transformation consultancy providing expert partnership and growth without creating dependencies or disrupting culture. We're also very proud to say that community is at the heart of everything we do, which is why we're so proud to sponsor Cloud Native London. There are two ways in which you can find out more about us. You can either DM me on the Cloud Native Slack channel, my handle is Megan Slater, or you can check out our LinkedIn page where we post our latest updates, blog posts and the like. I also look after one of Technovo's community initiatives, Meetup Mates. Meetup Mates is also very proudly partnered with Cloud Native London. The idea behind the initiative is simple. No one should feel like they can't attend the events that they're interested in simply because they have no one to go with. Given we're in quite strange times at the moment, community is now more important than ever. Our Slack channel is where like-minded devs can come together, discover the latest virtual events happening and discuss what they've learned. You can find out more info about us at meetup-mates.com, where you can also sign up. Just remember, meetups are better with mates. And that's all from me. I'll pass you back to Cheryl.
Awesome, thank you, Megan. Do we have someone from Pusher on the line? If not, I'm going to hand over to X Matters. I think I saw.
Yeah, thanks, Cheryl. Hi, everyone. I'm Nathan from X Matters. If you've not heard of us, we're a digital communications platform, basically helping you with orchestrating the various tools that you use as part of your digital services, but also with helping you keep connected to all of your teams. I appreciate a lot of you on the call today probably aren't used to working from home, so you'll probably find yourself connecting a lot more to your teammates through apps like this, through Slack and stuff like that. So we're here to basically help you with not only managing those communications between your teams, but also just helping you ensure that you're keeping your systems up to date. I don't know if anybody's tried to do any kind of online shopping in the last 3 weeks. If, like me, you tried to order some wine, you probably found that you couldn't because the websites were down. So we're here to help you with making sure that your platforms are keeping readily available for all your customers. Additionally, as well, we can also help with things like communications that have gone out in recent weeks to things like your employees, checking that they're safe and what have you. So if you had any comms from your business about coronavirus and what to do and what have you, we can help essentially make those a little bit easier. And if you are one of those people that doesn't work from home very often, forums like this are a really great place to chat to other people that are hardcore work from homers. So more than happy to share tips on how you can be effective with working from home. Thanks, Cheryl.
Awesome. Thank you, Nathan. Do we have someone from Humio? Souza? Okay, in that case, Ashley, do you want to take Palo Alto Networks?
Sure, why not? Thank you. Yes, Palo Alto Networks, big in the old firewall world, and now also moved into cloud native stuff. So that's how I've been involved and thankfully been allowed to talk as well at Cloud Native London. But yeah, so anything that we're doing from serverless functions, containers, all the full spectrum, all the way through to VMs that you're spinning up in the cloud, we think that's really, really cool and really, really awesome. And we want to help secure all of that and do it in a nice, friendly, shift left way is the very quick pitch for you. But you can find out more, Palo Alto Networks or Prisma, it's all there.
Awesome. Thank you so much, Ashley. And thank you to all of our sponsors for keeping us going in these crazy times. Okay, so back to tonight. I'm going to hand over to Dewald now to talk about the SRE journey at RVU. In half an hour, we'll have Amir speaking about SSL certificates in multi-cluster environments. Then we'll all take a 15-minute break and then reconvene to hear from Andrei about next generation platform architecture. And with that, I'm going to stop sharing my screen. And Dewald, over to you.
Thank you, Cheryl. Let me just get those slides up in this new and exciting format that we're having today. I'm also just going to close this window because motorcycles like to drive by in the middle of talks. That is just how that works. So let me just hit the share here, and I'll get those slides up in a second. For those of you who want to sort of follow on their own, the deck is on SlideShare. I'll dump a link in the Zoom. Sorry, it's on speaker deck. So I'll dump a link there, so so anyone who wants to follow along at their own pace can follow along there. Cool. So let me just put that in there. If anybody would be so kind as to send that out to Slack and possibly YouTube as well, just in case people want to follow along at their own pace. Okay, and without further ado, let's hit the present button here and see how long this laptop will keep up before setting on fire. As unfortunately, we have discovered working from home requires a lot more CPU resources. All right, so as Cheryl said, my name is Dewald. I actually am the lead SRE at RVU. And this is a story all about how, nope, that's the wrong one. This is a story about the SRE journey at RVU. Specifically how we even ended up looking at the term, how the term entered our nomenclature, and how we went from having no SRE anywhere, from sort of having a very loose view of how we operate things, to starting to roll these practices out throughout our company, and how we invest in that to today. So first question on everybody's minds, though, is who the heck is RVU? This is something that has come up. Now, if you have been spotting the logos at the bottom right there, you might notice that some of those brands may be familiar, and that you may know us better than you think. In fact, RVU is the custodian of an engineering organization behind the brands such as USwitch, the UK's top comparison site for home switching, Money, one of UK's leading financial comparison sites, and Bankrate, which is a changing the mortgage market. And so RVU is just a engineering brand for all of these organizations. You'll be seeing more content under the RVU brand in the future. So if you've seen stuff from USwitch before, we're the same people. We just have a bit of a broader remit now. And with that comes a lot more sort of focus on reliability, how we deliver services to our users. So now that you know who we are, it's important to start at the beginning. And so we will begin where the journey begins in 2017, all the way back when USwitch was still running on ECS. And now, since I know this is cloud native, I have to put a Cube logo in somewhere, and I can promise you that is coming, so don't worry. But we start on ECS. And if I had to draw a picture of the engineering organization in 2017, it would look something like this, a bit drastically simplified, but this is not an architecture diagram. Rather, we're sort of looking at each of our independent teams kind of operating their services, operating their data, and owning everything in the infrastructure all the way down to what kernel versions running on their hosts that ECS is using to orchestrate their containers. And this is pretty good setup. We have highly autonomous teams. They're able to use the services that are valuable to them. They're able to control exactly what goes on in their environments. And so one would wonder, why would we want to change any of this? But as you all know, I promised the Kubernetes logo, and so you know there is change coming. You see, one of the reasons that we wanted to change things is that we had a lot of teams, or many of our teams were doing duplicate effort. They were sort of re-engineering stacks all the way down. Some of our teams were not that great at keeping up with OS patching, since it wasn't exactly the highest priority to them. No shame. They had features to deliver. They had customers to satisfy. And so the kind of driving organization was to centralize a little bit of the infrastructure. And so there's that Kubernetes logo that I promised, and it arrives. And we formed a cloud infrastructure team. And like many companies, we started replatforming these apps onto a Kubernetes platform, slowly but surely moving one by one onto cloud and onto our Kubernetes platform. Now, I promised this was a talk about SRE, and we're currently talking about replatforming stuff, and I do promise we'll get to that. The problem is that to talk really about why we even have SRE, we have to talk about where the problem came from that got us started. And so one of the things that we saw as a benefit from all of this is as our team started onboarding onto our Cube platform, we started seeing more and more opportunities to simplify their operations. And this came in many different forms. In fact, one of the earliest forms was Heimdall, the alerter, a project that essentially allows us to define alert templates, watch for annotations on ingress objects, and then create alerts from the templates from those annotations. And this means that teams could sort of define their ingress as on the left with just an annotation saying, I want the 5xx rate to be below a certain amount. And we could apply a template on the right. A very early sort of primitive look at how we can automate a bit of operations work. And this was great because it was the beginning of a brand new interface between teams and infrastructure and operations. Rather than teams having to code directly against raw Kubernetes primitives or even the AWS API, we were able to provide them with a simple way of rolling these things out. And this interface is something we'll get back to because it's something that we kind of have iterated on over time and is core to our strategy these days. So this is where we begin. It's 2017. There's a love affair brewing, and we're getting going with our adoption. As we mentioned, we're rolling out a couple of shared services. Our teams are switching from their ECS clusters, and things are just about to get exciting. So we move on to what every great replatform needs, which is a great migration. We now have all of these teams that need to come over to our services, and it's actually being accelerated by GDPR. So as GDPR came around in 2018, many of our teams said, you know what, we actually want to spend our time focusing on our features. We want to be sure that we're GDPR compliant. We want to make sure that we're providing the value to the users. And so can you guys in the cloud team please run the compute for us? We no longer care about running these ECS clusters. And that provided a great accelerator for our migration, which is great. And it's nice to see more people onboarding and nice to see more teams to help. And you can see from this picture, a bunch more teams moved over. And we've got sort of one team on the left still running their own infrastructure. But most of the teams are kind of coming over to the platform now. They're sharing in the benefits. Cloud is rolling out, Prometheus for monitoring across everything. So teams no longer have to worry about coding individual CloudWatch alerts. And we're able to kind of leverage that platform of ours to give more service to our users. And another thing that GDPR helped us expand on is it provided another good reason to expand on that interface. Our teams were in need of good security practices. They required some way of ensuring that there weren't static credentials in GitHub repos or in secrets. And so along came Vault the Rotator, another project that we built that allows you to define a binding between a service account and a database, inject sidecars into pods, and those sidecars will then fetch the credentials based on those bindings. And so we can I'm drifting back here. But we can very easily sort of define this binding as just for the service account, make this database available. And this was another way that we allowed our teams to interface with another good practice. We're shoring up their operational practice. We're allowing them to get sort of 12-hour credentials for free. I think initially it was actually 2, and then we had some outages. So there's a story there too. And that was one way in which our cloud team kept expanding how we kind of amped up teams' operations. So here we are in 2018. GDPR is actively driving more migration onto our Cube platform. It also drove us into developing better security practices and more of the sort of operations automation for our teams, helping them get things done in a more easy way. And it all went well until the last migration, because there's always someone who is the last person to migrate to your platform. And they're normally the people that care the most about their platform. In fact, in our case, the biggest of our businesses was yet to onboard on our Cube platform. And if you haven't guessed, it is in fact that column on the left is in fact the energy business, one for which USwitch is known for. This business, however, is fairly special in that they are actually very, very effective at managing their own platform. They had the biggest team and the most capability. Within this team, they had engineers who were not dedicated platform engineers, but they had some specialized skills, and they were able to effectively run their own platform far beyond the time span that other teams had decided to hand that over to and jump onto the Kubernetes bandwagon. And from that effective platform management came a very interesting triggering conversation, what I like to call the founding question, which sounds very presumptuous. And that was this conversation where one day an engineer from Energy, while they were doing this last great migration, contacted the cloud team and said, we're seeing some performance problems in one of the pods that we've migrated onto Kubernetes. And cloud kind of looked at the situation, checked a couple of dashboards, came back to the energy engineer and said, well, it looks very odd because no one's actually raised anything, and I can't see anything wrong on our end. And Energy insists. They say, we've tested our app, we've compared it to our existing setup, and performance is definitely worse. And cloud responds at this point with, well, we don't really know what's going on. I mean, everything seems okay on our end. There's no cluster, there's no resource contention in the cluster. We're not seeing your pods run out of resources. We're not seeing our ingress get contended. There's nothing on our end that seems to indicate a problem. And this is not truly where the conversation ends. This is a bit dramatized. Obviously, these engineers went forth and sort of did an investigation to find out what went wrong. But this conversation is so key because it highlights to us the 2 problems that kicked off our whole SRE journey. And that's that Energy had an expectation that the performance on the shared platform would match their existing infrastructure. Now, whether that expectation was founded or in reality or not is a different conversation. Should they have thought maybe this platform is slower? Well, they had no reason to. There were no indicators to them that this would be a problem. Cloud, on the other hand, had no indicator for the expected performance level and whether it was being met. This means that for cloud, as long as no one was highlighting performance problems, it was business as usual. As long as all the clusters had enough resources and the pods were running and the ingress pods were not reaching the sort of running out of CPU, that everything seemed hunky-dory and kept running and ticking over. But this highlighted this key problem that there was an expectation from the one team and that the other team was unable to answer that expectation with a defined answer. In fact, this is around the time where the founding question is asked. As I say, we have the energy team migration beginning and questions start to arise about the platform's service levels. And so from this, we see the first service level objectives emerge. For those of you who have read the SRE nomenclature or the SRE books, for those of you who have not seen that service level objectives, there is a bit of a description down the line, so stick with me. But our first objectives started to emerge. And they started because of these two problems. We needed something that could help us answer energy's expectations and help cloud have a deterministic indicator of when they should be responding to situations. Cloud, in other words, cloud needed a way of defining, measuring, and publishing their service levels, not just measuring them on a dashboard that they owned and not just in the moment. And so we come back to the SLO. We define in the service level indicator to specify the desired reliability, and we set a service level objective for this indicator. Many of you will have seen this many times before, but for us, this was groundbreaking at the time. The idea that we should be setting objectives rather than just measuring an arbitrary thing that says we're fast enough right now. And this is actually a sort of very slimmed down version of what came out of that very first SLI discovery for the team. We started to measure the proportion of requests to a dummy application that respond in less than 20 milliseconds. With some sort of digging and investigation, looking at our existing data, comparing sort of the data between our ingresses and the load balancers and further ingresses, we could kind of start to figure out how much each step in the process was adding to the latency of a request. And we reasoned that we should be seeing about less than 20 milliseconds in 99% of the cases. And as it turned out, when we measured it, it was about 86%, which is not the world's worst measurement, but being P86 when you expect to be P99 is a pretty scathing indictment. But what this did allow cloud to do, what this very crucially allowed them to do, is it allowed them to actually start measuring and put a plan in motion to bring that service level back to the objective of 99%. Seems pretty straightforward. Again, revolutionary at the time. Now, using that, we can solve our original two problems and kind of even go beyond that. So our original problem was that the energy team didn't know what to expect. Well, now there's a defined service level. They know what to expect. Cloud was unable to answer the question of stuff seems slow, what's wrong? With, well, now we've defined a service level that allows us to prioritize when we need to actually investigate whether things are fast enough, and allows us to become aware of when we are actually failing and not realizing it. And the free thing that came at the end is that as long as cloud met and exceeded this objective, it was free to pursue other tasks. It didn't need to spend energy and time investigating more ingress-related problems. So here we are, mid-2018 by now. Well, it's sort of end 2018 actually. Cloud introduces the first service level objective for the platform, and we start to see a little bit of a shift in the mindset of how we operate this Kubernetes platform. In fact, it was so successful that cloud continued to roll out more SLOs to cover different aspects of the platform. Some of these include things like cluster DNS. Another question that actually came straight from the energy team. We think DNS is slow, and we had the answer this time. We'll go figure out how fast it should be, and we'll set an objective for that, and then we'll meet it. And that actually worked. Logging was another one that came up. Every so often an engineering team would say, we are not seeing our logs, or is there something wrong with the logging pipeline? And so we set some very simple freshness SLOs to say, well, the logs in our logging system should be fresher than a specific boundary 99% of the time, allowing ourselves some leeway for sometimes when the pipeline backs up, of course. And so we can easily see that as we move along, we keep extending the SLO coverage to cover additional parts of the platform. We're making very defined statements about what we will support, even internally to our own teams. This is not a service that we're selling to customers. We're not a Kubernetes operator. Our customer are these internal engineering teams. And yet we're treating them as an external team that we can provide these SLOs to, provide these service levels to, and guarantees to that they can jump in on. Well, as you can tell, we're not quite at the end yet. We're getting close to the modern day, but we still have one more story to tell. And that is, oopsie, not that one, the other way direction. And that is the actual birth of SRE, because up until this point, I've been talking about a platform team rolling out SLOs on their own. But this can go so much further than that. In fact, one of the things when we looked at our organization, having finished these migrations, having moved people onto the Kubernetes platform, having sort of inside of our cloud infrastructure team decided to roll out these things, we thought this could be of so much benefit to the rest of the business. Each of these teams might operate their services, build, run and own their services independently, but they depend on each other sometimes for data. In fact, in our current world, with more brands than ever, we're seeing a need to have more structured integrations between our different teams. And we thought SLOs and the SRE practices that follow are a natural way to roll that out. So the question then is SRE just another team? If I say that it's the birth of SRE at RVU and then show you a picture with another team on it, you're just going to ask me, is it just another team that's going to make dashboards? And the answer is yes and no. It's a bit strange. You see, it is definitely another team. It's definitely a distinct discipline, but it's not a separate discipline. And so it's not a team that tends to own its own work necessarily. I'll get back to that in a little bit. Teams in our space still build, own, and run their services and applications. So we did not create an SRE team with the ideal that SRE should take over operations for these teams. We did not create an SRE team with the idea that teams should no longer be responsible for being on call. They should still be very coupled to how their service is built, run, and deployed ultimately, because the buck stops with them as the users rely on them. So what did we want to do? Well, we wanted to work alongside our platform and product teams to adopt modern operational practices. We saw inside of our cloud team that when we responded to a situation with, well, the current latency on X is fine, that was not a good enough answer as to whether our platform was doing well overall. And we started to wonder if this was the same thing that our users were seeing. If users came to Switch Energy today, and today the website was a little bit slower, did they notice? Is that something that we should be investigating immediately? So that is essentially what we're working on. We're working on helping our teams better define the relationship between them and their customers. And we're doing so by adopting these SRE practices that allow us to set very definitive boundaries between these relationships. Now, this, of course, is the business slide. If you ever have to sell this to your manager, you just show them this. I guarantee you they will look at this and they'll go, that says maximize and change velocity. I'm in. What is this change? Because at the end of the day, that is the ultimate goal. The ultimate goal is to ensure that we can go as fast as possible without breaching these objectives. And breaching these objectives means that we can go as fast as possible without compromising on the service we're delivering to our customers. So this is one screenshot. You're welcome to copy it, stick it in a presentation, show it to your manager. It worked for me. So please go ahead and use it. And here we are now at the end of our timeline. The SRE team is formally announced in mid-2019, a fairly long time after we actually started SLOs in cloud, as we had quite a bunch of spooling up to do. But our team is formally put together. We now have a remit to help teams go faster while they, sorry, got completely confused about, to maximize change velocity without breaching service level objectives. I should know that one by now. And we also have a sort of sub-objectives of helping these teams reduce their operational burden day to day, helping them understand when they need to be doing reliability work. And so now we catch up to the present. And that present is that what we are doing in our organization is trying to roll out as much automation across operations for everyone. I mentioned before that SRE is not a team that kind of owns its own work. And I said I'd get back to that because I wasn't quite being truthful. And that's because we do own the job of trying to make everything in operations easier. So we do actually own our own work a little bit. And what we're doing to achieve that is we're using that interface that cloud kept expanding on, that really good the really good interface of having teams define things as Kubernetes objects because they're already used to using those primitives on a daily basis. In fact, the first thing we built is an SLO controller. And so this is something that there's still a ton of work for us to do on this, and it's very early days. But so far, It allows us to define a set of SLOs as a combination of metrics, selectors, and objectives over a Prometheus Prometheus instances. It creates Prometheus recording rules to pre-calculate all of these SLO values, and then it generates dashboards on Grafana for teams to view these SLOs. And at the end of the day, you can see that this is just another Kubernetes ingress object, Kubernetes object, service level objective. And it basically defines a specific type of SLO, either a counter or a histogram-based one, with some selectors, either how do we determine what is good and bad, what kind of information we have, and a kind of textual description that we can use on our site. We also define the period and the objective in there so we can ensure that we pre-calculate all this for users. And this actually results in a fairly simple looking at this stage dashboard. This specific one we're looking at right now is a screen cap from earlier today of our ingress dashboard. And if you peek there right at the start, you may see that we may have had an incident. Was it last week? Yeah, it was last week. So that's an interesting one to see. I was like, being honest. And this is kind of a snapshot of what it creates. And at this point, it's still very primitive. We're working on a lot of different features. In fact, I have a whole list of them that I'll share with you in a little bit. So that was step one. Step one was, can we easily allow our teams to define these things in a language that they understand and then let them roll it out? Because what we ultimately found is that teams really saw the value of these practices, especially after being shown their current performance using SLOs. We had so many teams who said, oh yeah, we're easily at 99% under 500 milliseconds, and then they weren't. Or teams that said, well, we think we're just about keeping up at 90% under 90% of 200s, and they were like 99.995. So showing them this data, especially over a longer period of time, as SLOs teach us to do, really help them kind of look at it and say, oh, this is actually what our users are seeing over time. It's not the current instantaneous response that we care about. It's that sort of view. What have all of our users over the last 28 days seen? Teams that have adopted these practices as well started talking in terms of relative terms about reasonable reliability. Teams now tend to talk a little bit more, not all the way there yet, but we're getting there, where teams talk more about, well, we're okay with this amount of failure, or we don't necessarily need all of this reliability. There's definitely some work to do here still. Engineers will always tend to bias towards, well, we need 5 replicas come hell or high water, but we're working on it. And it's definitely something that bringing these SLOs to front have shown teams that they're actually meeting these objectives and they don't need to worry about every 5 errors coming down the pipeline. The question then is, can we actually take this further, even beyond the server side? And so we rolled out Fastly metrics. We wanted our edge to come into our Prometheus so our teams could use that. And so we added syslog to Fastly. We pushed some JavaScript into the browser to capture that data from the browser, and we ingest it through the logs, and then create metrics server side. And so at the end of the day, we're able to now, inside of our Thanos clusters, query the actual time to interactive that our users are seeing for different pages across our site. And this, of course, can then be very easily, using the SLO controller, can be turned into performance-based SLOs. The teams can hold themselves to, capturing things like what happens if we add additional Google Tag Manager tags. Does that actually slow the site down? Let's measure that in our SLOs. Of course, here's an example dashboard for our current homepage in production. As you can see, well within budget. I'm very proud of that team. They definitely set some pessimistic objectives, so we will be reviewing these, I'm pretty sure. And we can see down here that we're capturing that live time to interactive all the way from the user's browsers and getting that sort of in a near real time as an SLO over the last 28 days. But we have to care about the bad times too, because sometimes things go wrong. And therefore we have an incident bot. I mean, who doesn't these days? But you know, we built one when it was cool. You ask it to start an incident, it spawns a channel in Slack, it invites some people, or at least yourself, and generates a report when you tell it that you're done. Another form of just a little bit of incident operations automation that we're vastly looking on expanding on. And that was just the beginning of where we started when we got going with this. We have so many things in the future at SRE that we're looking to do. And this is really exciting because a lot of this tooling that we're talking about right now, it's either open source or we're open sourcing it very soon. We want the community to jump into this because we have a list of features and we think you guys might have even better ideas. And maybe if this is useful to us, it would be great for you guys to use as well. Some of the stuff we're looking at adding is automated alerts on error budget burn rates. We want to be able to say, well, this specific error budget is burning at a really high rate. It's going to exhaust itself in less than 2 hours. We need to summon a response. We don't want teams saying, well, if this value goes over 100, send me an alert. We want teams to say, what is the aggregate? Are we going down? What happens on the trend? The trend is so important. Connected to that is displaying the time remaining until error budget depletion. So teams can really use that to decide, should we be prioritizing reliability work? This says it's going to exhaust in a week. Maybe that means we should start putting things on the backlog to tackle this. Maybe it's not an immediate problem, but it's something we want to kind of give visibility on. We want to have escalations happen based on service classifications. So we have the burn rate, we have the time remaining at the depletion. Now, if we know that your service is a really important one, i.e. the money maker for the company, we can use that understanding of a classification to set a specific escalation policy so teams don't have to worry about that. And then finally, well, not even finally, we've got a whole more slide to go. We want to build out an automated load testing platform to help teams understand more about where they're setting their error budgets, how they should be using these error budgets, what are they going to look like under a scale situation. And based off of that, we want to use that automated testing platform and our SLO budgets to use that excess error budgets for load and chaos testing in production. We found that the best way to load test, yeah, just fire it at production. If you've got error budget, it's fine. We'll burn a couple more errors. It's okay. We're measuring this. We're on top of this. Maybe we find that users complain and we realize based on our load test, actually, we should be setting those objectives higher. Users are starting to experience too many errors. But you can't discover this without setting these budgets and then playing with them in the first place. We want to have SLO budgets, error budgets and SLO budgets for non-technical solutions as well, for compliance incidents, for anything outside of the technical domain, maybe for SEO conversion rates. There are many things we can try and use these things to set budgets on. Perhaps not as a term SLO, we might change the wording, but we would definitely use the concept behind it of setting a target and targeting it. And then finally, we want to discover new things to measure and set SLIs on. We want to discover things that we can measure that explain our users' behaviors better so that we can better ensure that they are up and running. So, and finally, as I mentioned, we want to open source as much of this as possible because it's not something that we really sell. I mean, why not? We use so much out of the community. We'd be so grateful to hand it out and have people use it. It'd be amazing. So, I need to wrap up. I'm actually, I think, slightly over time. I'm really sorry, Cheryl. Obviously, the dry run went better than this, but yeah, it's good. So I need to sort of wrap up really quickly, and I'm going to just jump through these last couple of thoughts before we finish up. So the first thing is, do not adopt SRE practices because it's the next cool thing after you've got a kube cluster, right? Don't do that. It is very difficult to convince people to even start looking at something like SLOs. If the teams have monitoring in place, if they have confidence in their solutions, it's going to be difficult to talk to them about how to change their operational stance, how to think in terms of error budgets rather than responding immediately to a problem or an alert. And so trying to adopt it just because it's a cool thing is going to be hazardous. In fact, do listen for those conversations when engineers feel or think that their systems are okay. Think back to the conversation that triggered all of this. When somebody came to cloud and said, something looks wrong, and another team was unable to say, well, it should or shouldn't be. That is an indication that there really is a gap for that team to adopt some kind of expectation, maybe in the form of an SLO, that allows them to reason about that reliability and allows them to integrate with those teams. If you have teams integrating services with one another, that's an excellent place to start. If you find people who are having these conversations, they are so much easier to sell this to because they already know that there should be a better way than answering a question with, I think we're okay. Automate as much as possible, far beyond deployments and infrastructure. Automate dashboards, automate incident response, automate load testing, automate everything you can, because at the end of the day, the more operational burden you can take off your teams, the more time they have to iterate, improve, and deliver better solutions to your customers. And at the end of the day, remember that's underpinned by your SLOs, hopefully underpinned by more automation. And then at the end of the day, know that SRE is hard. It is hard to get people to adopt these things. It is hard to teach these practices with just a workshop. It is hard to convince people who are bought into a different way of work that there may be a way that they can track these things that will give them a little bit of leverage and advantage. But we can find ways to make it simpler to adopt. Using automation, using automation, using that empathy of listening when someone is having a situation and finding out when we can jump in to really get them going on adopting these modern practices. All right, that is it for me. I am a liberal 3 minutes over time, so I'm probably going to skip questions if that's okay, Cheryl. But do message me in Zoom or on Slack. Alternatively, get in touch, and I'm always happy to have a conversation. Slide decks on speaker deck, as I said. I've been Dewald. Have a good day, guys.
Thank you so much, Dewald. That was amazing. Thank you for presenting. And yeah, if there's questions for people, please put them into the Zoom chat. If you're watching on YouTube, I can forward them on to Dewald as well. So Amir, would you like to take over as our next speaker?
Yes. Let me share my screen.
Perfect.
Okay. Gonna real quick open the presentation. Perfect. Everybody, I hope everybody see my screen.
Yep, looks good.
Cool. So hello everyone, and thank you for joining. My name is Amir Avraham. I'm a DevOps lead at Alcide, based in Israel, and let's get started. I'm gonna talk about today about managing certificates in a multi-Kubernetes environment when you have different clusters, production, prod, staging, dev, and on different clouds. So Azure, on-prem, GCP, you name it. Just gonna give you a bit of background. So we are doing Kubernetes security. We are all of our services is on Kubernetes from day one. And about a year ago, we kind of moved into a multi-tenant solution. And just like every DevOps and SRE teams, once you move into a multi-tenant, there's a lot of going on. There is a database migration, there is a scaling, there is a resource management. And one of the challenges that we end up running into is managing certificates. It's one of the challenges. And what we ended up doing is the solution was with the main ingredients were Let's Encrypt, which I want to talk about them in a second. They were a public free CA based in San Francisco, acme.sh, that it's a GitHub open project, open source project that I highly recommend using, and a little bit of our DevOps touch. Certificates. So our main pain points were that using a public CA, like, I don't want to say names, but the ones that you pay for, okay? It's a long verification process, very manually, meaning you need to talk to them, you need to call them, you need to send them all this kind of forms that prove that you're a true company and you're paying rent and paying the electricity bill at your office and your location, which is definitely not the DevOps way of doing stuff. DevOps stuff should be fully automated and easy and fast and scalable. And that solution was just not a good fit for us anymore. Also, there is a high cost. We're using wildcard certificates for our production staging environment. And as you can see, I put an example over there in the left bottom corner of the screen, that 1 year per one certificate is like $700. When you need to use a few more of these, you ended up spending a lot of money that you not necessarily needed. And obviously dealing with replacing, which is always a nightmare. Of if you didn't automate it, and it's kind of, again, it's one of those things that you need to automate, and it happens once in a while, and you forget about it, your service is down, completely down. And it's always public facing. It's always customer facing. So I'm about to show you something. I'm about to show you the solution that we use, but it happened to us. Right? It happens to everybody. And if you've been like me in the IT world for many years, it happens. So the solution was using Let's Encrypt. So Let's Encrypt, like I said, they are an organization based in San Francisco. They're a very small team that did an amazing job operating public CA. So they'll give you a public certificate, a wildcard or named one, and it's valid for 3 months. So you need to change it every 3 months, where other CA normally gives you 1 year, 2 years, 3 years, or sometimes 10 years if you're a bank or federal or something like that. They have a staging environment, where at the staging environment you can ask as much as certificate as you want. They won't be valid, they won't be assigned, but it's mainly for your staging. So once you're building an application that is based on their API, on their Let's Encrypt API, it's normally the best practice to use that URL, that staging environment. And once you move into production, you can ask for 5 certificates from the same kind of, we'll call it FQDN. You can ask up to 5 of them in a week, and then you need to wait 7 days. So if you pass that limit, if you ask more than 5 times, you need to wait 7 days, and there's nothing you can do about it. So if you're doing testing and you're staging or developing, work with staging. If you're not, and you're in production, use the production one. The other project that I use is by this gentleman, Neil Pang, and is GitHub resource. It's ACME.sh. ACME is a protocol for negotiating certificates between the requester and the CA. So let me jump before I jump to the next slide. So also what we did is we're using Jenkins as our CI/CD platform, and we kind of split the CI part and the CD part. So the CI part is a Jenkins pipeline that is responsible for generating and checking if renewal is needed on global. And the CD part is how we deploy it to our clusters. And we're using Helm. We're still in version 2. We're kind of migrating easily to version 3 to get rid of Tiller. If anybody is familiar, it's version 3 was introduced a few months ago, and it's highly adaptable. So as I said before, the pain points on that was Let's Encrypt only gives you 5 renewals per week. It's a hard limit. There's nothing you can do. You cannot talk with them. You kind of, if you didn't save the certificate, or if you use some project like Cert Manager, and you're spinning up a new cluster or a new environment, those certificates will be lost. We're multi-cluster implementation, so we are running. We're running on 3 clouds, so Azure, Google Platform, and Amazon. And we didn't want to be bounded to one of those. So Amazon has their, they'll give you a few free certificates to use. And we didn't want to be bound to one cloud because we're using multi-clouds. And so we didn't want to use a vendor-specific or a cloud-specific solution. We kind of wanted something that is open source, backed by a community, and kind of tailor-made it to our environments. There's a beautiful, amazing project, but I'm sure everybody, if you've been around Kubernetes for a while and you're dealing with online environments, you'll heard about Cert Manager. So we are using Cert Manager, but it's for a different purpose, for customer-specific certificates, or kind of single certificate on a single cluster. But for our multi cluster environments, we're using Third Sync. Another thing that's about Third Manager that is not supporting a multi-cluster. So if you have a cluster that is running Third Manager and is requesting a certificate, and then you spin up another cluster, which we are spinning. So in our kind of dev and staging environment, we're spinning something like 30 clusters a day on different clouds because our product running on different clouds and we need to test it. So we're spinning up, we're doing the checks, we're taking down the cluster, and using Third Manager will not help us because it's running in one cluster, it's inside a cluster, and it will ask for a certificate, it will get it, but the next, let's say after the fifth one, it won't get it. They will be banned. So it's a cool and it's an amazing project, but it wasn't just good enough for us and for our skills. And over permissions is something that we're kind of looked into it because we're heavily focused on security and Kubernetes security. And one of our solution was when we started to think about it, we understand that this entity that we're building needs to have read and write access to the cluster secrets, which it's a challenge. You want to minimize the items or the service accounts that have such an access, but I'll show you the solution and what we did in a second. So the solution is the first part, as I said, is a CI pipeline. So it's a Jenkins pipeline that is running the acme.sh wrapped by another bash script that we built, which will upload a certificate to Azure Blob. This is where we store it. And the way it works is this, is we're checking if renewal is needed. So there's a certificate the certificate that we generated for the first time. And if a renewal is needed, then the pipeline will kick. Okay, and the way we define it, so you get a certificate for 90 days. If the renewal date is if the expiration date is less than 30 days, this will kick in. And I'll show you an example in the next few slides. If renewal is needed, then we're downloading the last acme.sh version. And the next phase is to do a DNS challenge. So DNS challenge is, this is the way that's Encrypt doing the verification that you own the domain. So that what they ended up doing is you're going to their API, you're requesting a certificate, you give them all the variables like what's the domain, wildcard, not wildcard, and they reply with a token and a DNS entry that you need to put on your DNS. This is how you authenticate and say, okay, I own the domain, I control it, I have read and write access to it. And the default time is waiting 20 seconds for the DNS to be updated with the entry and token that they gave you. And after that, certificate generate will be happened on Let's Encrypt side and will send back to you. Once it's done, so the next phase is uploading those certificates to our Azure Blob, or in your case, it could be Amazon Bucket, or you name it, or any other cloud. And the next phase is actually, so you generate a certificate, you put it in a centralized location that everybody can access it, whoever has permissions and credentials, etc. Then we thought about how we're going to put it on different cluster and kind of have a state and maintain that state if they have it or don't have it. And if they have it, they talk with that. They kind of don't talk with the CA, they talk with our bucket, and then we kind of fixing that 5 requests. We're avoiding that 5 requests per week because there's only one entity that is talking with the CA. And what we said is we're going to put a pod inside of, it's a deployment, obviously, which will run a pod in each cluster, and it will be part of our product deployment and other services that we do deploy. And that pod has access to, it has a service account that has access to whatever resources it needs inside each and every Kubernetes cluster that we're running. And that pod is basically running that get certificate from a blob, which is a bash script with all the parameters it needs. It gets the certificate from the local secret in each cluster, and it checks if the serial number is different on the secret, which is installed on the cluster, or the one on the blob. If it's a match, if it's a match, then there's no change needed. The certificate is okay. And if it doesn't exist or the serial number is not a match, it means there's a newer version in the blob, and it will go fetch it and will kind of write it to the secret inside the local cluster. Okay. So one comment on that so if you have ingress or other stuff that is dependent on that public certificate, and it requires, if you change a certificate, sometimes you need to make sure the backend service, like an Nginx service that is using it, we need to do a restart. This is one of the items that we found out that we need to take care of as well. So in Kubernetes, if you use the patch command, it will let Node know about the change. And if there is services that is dependent on that kind of change, they will be updated. So we are either creating, if it doesn't exist, or doing a live patch and kind of edit the secret and replacing it with the new values. So what about security? So we ended up with a very fat pod. When I say fat is, we try to run it with Alpine, which is a very, very, whatever is not familiar, it's a very skinny kind of Linux distribution. But we ended up adding OpenSSL because library, because we needed it for kind of reading the certificates and values. We needed some Amazon and Azure tools to be installed, which adds a lot of stuff. And we ended up with a pod that has, it has some resource that it needs, and it has read and write access to our secret in every cluster, because there's no really good way to limit access to different secrets or specific secrets. So we kind of did another redesign, and we decided to turn it into a cron job, which back in the days, it wasn't, cron job wasn't supported. Now cron job is, it's a native part of Kubernetes, and we decided to turn it into a cron job. And that cron job is actually running, in production, we kind of run it every 1 hour. In different environments, we kind of run it something like every few minutes, because sometimes we're spinning up a cluster and we don't want to delay the pipeline or the workload over there that is dependent on that. And with moving this into a cron job, we kind of eliminate the need of the pod that is, the deployment that is running in your cluster all the time, right? And just running the cron job inside of a pod or something like that. So using cron job as part of Kubernetes native is just amazing, because it's run, does whatever it does, and shut it down. You kind of eliminate the attack surface of that pod. And this is the kind of YAML for the cron job itself. It's part of an Helm chart that we're going to publish very soon to the community, so everybody can enjoy this. I'm still working on kind of removing parameters and kind of make it more publicly and not specifically to us, but it will get there. And if somebody want to be on the beta users, just ping me and I'll add you to the list so you guys can use it. And it's definitely a better efficient use of our resources. And another thing that I kind of forgot to read is moving to cron job and kind of drive this into something that will not run all the time, and reducing the attack surface is definitely something that we got internally by one of our products. So we have the Alcide advisor, which I'll show you how it runs in a few minutes. But it's definitely one of the things that pops out over there and said, hey, you have this pod that is running all the time with all this permission. Is that okay? Is it not okay? Did you really intend to build it that way? And I'll show you this in a few more minutes. So housekeeping. So that, like every project, there's definitely housekeeping that is needed. As a DevOps guy, I'm trying to make sure that my engineering teams are cleaning after themselves, and me cleaning after myself, not just saying it's engineering. And definitely in this project, I had a lot of cleaning up to do. And I'm going to show you, kind of a feed way of cleaning stuff and making sure housekeeping is clean and set to our levels. And this is, kind of the normal stuff that I see, then I hear from DevOps community out there, SREs, cloud architects as well. This is normally when I help, I ask them, when you, kind of take something from dev into staging to production, how do you clean after yourself? How do you make sure everything is, everybody did their job? And there's, right, there's everybody uses best practice of coding, and there's always security people that are involved. But it really, about housekeeping is like, how do you make sure people are kind of, stick to the policy, or doesn't put secrets in config map or Amazon keys, and how do you clean it and how do you catch it? So so what we are really good at is detecting orphan objects like Amazon keys and secrets and passwords that are just in a config map or in environment variables and stuff like that. Versions that are old. I don't know. It can be a Kubernetes part. I'm not talking about image scanning. I'm talking about patch level on your Kubernetes clusters. If there's something critical about it, or major CV out there, dangerous file system path or file system access from the pod level to the node level, and resource that is lacking liveness and readiness. So if you're, and you should have a policy that is saying that everything in production and in staging should definitely have readiness and liveness. So you kind of make sure you're protecting your cluster from eviction or from overrunning different applications, and especially in a multi, if somebody's working in a multi-tenant and you're hosting, that's definitely something that you should take a look at. So Alcide Advisor is one of our 3 main products at the company, and it really helps with all of this items that we see on the screen. That it scans your, it's kind of a deployment with one pod that will run inside of your cluster, and it will scan the entire configuration and will tell you, okay, it will scream about all the stuff that is critical, high, and we're definitely focused on high and critical. And we'll tell you, okay, this is wrong, you should fix it, and this is the resource that has the problem. And I'll show you a real quick scan in a second. And let me kind of take you to, so just to show you the pipeline. This is the Jenkins dub. This is how it looks like, and kind of show you the steps. So it's checking if renewal is needed, it's downloading, it's doing the DNS challenge, it's uploading the certificate. This is the kind of cool UI, the CI part of Jenkins. And we actually had renewal like a week ago. I'm using K9S. It's a very cool tool to use when you're using Kubernetes. I'll show you an example. So namespace, okay, it's a CLI tool that works with one cluster, and you can run it on different clusters, but or multi-clusters. But K9S, I highly recommend using it. So let's say I'll say cron job. Okay, so it shows we only have one, and it's this is a London demo cluster that I set up in GKE. It's running, this is the cluster, that's what it's running, and it has a lot of components that I can show you, but what I'm going to focus is on the cron job itself. I'll click D for description, and we can see it's running the third sync, it's running beautiful. And what I'm going to do is kind of, let me see if I can delete I'm going to delete the certificates, and it's running every minute. So what we should see next is on our pods. If we'll scroll down a bit, we should see, sorry, here we go. So we'll see a pod is creating and still running. And if we'll look at the logs, so it's kind of get the, listing the blob, getting it gets the file from the blob, and this beautiful colors saying that, in this case, because I deleted it, it recognized that there's no certificate from the Kubernetes cluster, meaning the certificate is not present on the local cluster. And it did recognize the serial number from the blob and say, okay, it's not a match. It will change the certificates and we'll install it and deploy it. Okay. And if it's running every minute, so I need to talk with you for like 10 more seconds. Here we go. Not 10 more seconds. And if we look at the logs here, we'll see that the serial numbers are a match. Okay, so it won't do any change. It only took it like 6 seconds to run. And you see the serial number from the cluster and the serial number from the blob are okay. Doesn't do anything, just will run in the next 1 hour or whatever time that we'll say it to run again. So it's very easy, it's very straightforward. It's a solution that kind of, you do it once and you kind of forget about it. It's working, it fixes all your problems, and you don't have to pay anybody to use certificates, and it's a wildcard, so you kind of use it everywhere you want, on every cloud, on every environment. Let's go back to Alcide Advisor. So this is the Alcide Advisor. This is our dashboard for the advisor, and just to show you the infrastructure. So we're running in GCP. We have one cluster of Kubernetes. We're running on Docker. And this is the different workloads over there. So we can see, I don't know, let's see what we have here. Proxy, different Nginx, Ingress, Ignite, Kafka, it's different applications that we're using. So I'll take you to Alcide Advisor. We can see that we can run a policy and say a policy of scanning for PCI or for GDPR or HIPAA, whatever you're kind of focused on and want to scan your cluster. I'll just go with the default one. I'll click scan now, and scanning launch should take 1 minute. We'll go to the dashboard, and this is the profile we choose. And as we can see, we have different critical items. We have high, medium. Normally I focus on critical and high. And I'm sure everybody else doesn't have time to deal with lower medium and low kind of findings. And let's take a secret hunting, for example. So it will, it will show you that you have somewhere you have a secret in your config map. Okay, so you can drill down and go search for it and find some familiar stuff. Let me show you just another one that help you. And this is a great tool for housekeeping, right? So you define a policy, and let me do select all here. And I don't want to do it just on.
Amir, just to let you know, a few minutes over.
Okay, so I'll be again. This is I'll be finishing in a second. Sorry. It's a great tool for housekeeping. It will show you about stuff about pod security and API access and all the findings that it finds. And it's a very cool way to kind of scan your cluster and make sure that you don't have any findings, any threats, any stuff that you don't want to have inside threats or whatever. That's it. If you're interested in the chart for the third thing, ping me and I'll share with you the beta group. And thank you very much for listening, and be safe.
Thank you, Amir. Really appreciate you sharing all of this with us. Yeah, I guess if anyone has questions, then they can put it into the chat, and Amir, you can answer through there. Otherwise, we're going to take a 10-minute break now. So feel free to get up, stretch your legs, go refresh your drinks, and then we will be back very shortly with our third talk. I just noticed, Brendan, you said it would be nice if Zoom added an applause button. That's actually a really good idea. I agree with you. It can be a bit quiet, although I'm sticking around. So if anyone wants to chat, I'm here.
I had to help push a sofa up a set of stairs today. My back is killing me. Yeah.
Moving house?
No, like we have so this is our sitting room, but we have a separate room that my partner's computer's in. And we decided to get like a sofa in there as well. It's like it's like one of those with the back that sort of folds down. You can make it like a sofa bed.
Yeah.
So yeah, they delivered it, and because of this whole virus thing, they're not like putting things up into people's houses. They pretty much just like dropped it outside and left. So yeah, it's only 80 kilograms up a flight of stairs. So I was being sarcastic on it. It was horrible, and my back's killing me.
Oh no. Oh, I'm sorry to hear that. Yeah, just reminded me that last night I got a food delivery, and by the time that I got to the front door to pick it up, the guy had left it and vanished like all the way down the garden and just disappeared. I mean, must be pretty good for delivery drivers. They just drop it and go.
I imagine it is, yeah.
Yeah, that's happened with all the deliveries those days. Everything that you deliver, you need to be delivered at your home from Amazon or whatever. They do the same thing. Leave it at the front door and just run.
Yeah. So surreal.
I had a package delivered the other day where they, like, instead of requiring a signature, I had to answer the door. And they put the package in front of the door with the door open and had to take a photo of it. But he wasn't allowed to hand me the thing to sign. So
I did that too. They took a picture of basically my legs with the package. And I was like, I don't know if that proves that maybe somebody else has the same legs that I do. I don't know. That proves that they really delivered it.
Another one made me hold it up. So like there's some delivery driver has a photo of my arm just holding a package in front of my front door. So
so strange. So weird this. Looks like we are back on. All right, I'm going to stop sharing, and Andrei, you can share instead. Welcome back, everybody.
Thank you. Let me start sharing. Desktop. Okay. No. Desktop. Yes, this one. Okay, perfect. Let's see. Format. Okay, so what I want to present today is to give a little bit of glimpse of the next generation platform architecture and how and what styles should be taken in consideration when you start architecting a new software solution. So a little bit of background of myself. So I'm Andrei Cioaca. I'm currently part of Capgemini UK as a lead cloud solution architect in the cloud services practice. Previous experience with only in consultancy in Deloitte Digital and Data and IBM. I'm doing this in the last, I think, almost 20 years. My interests are mostly in microservices, API integration, and cloud technologies, and of course DevOps monitoring and the additional things that come together. So this is my own opinion. So I wanted to make it clear that it's not the view of Capgemini or my current clients or my past clients. And yeah, let's start. So you start your business comes in your department, and they require a new platform to fulfill those business requirements. So this is basically how most of the conversation starts, and in consultancy, this is how you you end up engaging with customers and with different clients, and try to help and solve their problems. So what happens when you need to start a new platform? So one of the things that is very important to think about on an architecture style that will drive everything going forward in terms of choosing the right technology, choosing the right infrastructure, choosing how you'll manage deployment cycles and so on. So one of the questions that pop up in different conversation, it's this most of the time. Should we use a monolith architecture, or should we use microservice? And surprisingly, the first part, the monolith part, pop-ups quite a lot in different organization, and if you are engaged with let's say large organization, you will end up in the situation like they say, okay, the monolith, it's the best way to do it. We did this in the past 20, 30 years, and we want to stick to that. And you need to kind of have a very good speech behind you to fulfill and to argument that, okay, this perhaps is not the best way to do it, and so on. So as I see it as a critical review when you start to provide your architecture style for your platform, and it's also choosing the right architecture style for your platform. It's also like I said, a critical review step in your design, because if you realize at the middle of your timeline that your platform is not designed in the proper way, it will be very hard and not cost efficient to change it.
Andrei,
yeah.
I think a couple of us can only see the first page, the title of your presentation. I don't know if you're expecting to show a different page.
No. I'm already in a 4th or 5th slide. Okay.
No problem.
Let me see. Okay. Okay. Okay, what you guys see now?
Yeah, I see. This is critical review. Your mileage may vary.
Okay. So yeah, like I said, when you choosing the right architecture, it's a critical step in your going for your success, and will be critical on how successful your program or your project will be. And in terms of platform architecture style, there are many architecture style existing right now, and you need to understand and tailor your style based on a couple of based on couple of decision, based on your organization, based on what is the activity domain that your organization is doing, based on how it's your department structure and so on. Your technical guys, what is the technology landscape that you use, what if your IT department it's more focused on cloud architecture, or it's more on old style, I'll say, architecture. And okay, I think I skipped one slide. No. Okay, and there are a couple of architecture style that you can start looking on when you first start this kind of discussion. There are the well-known event-driven architecture, public subscriber, the client server that was used back in the day, of course REST, and so on. And besides all those 6 that I put it here, there are more and more architecture style that can give you a glimpse on how your platform should be architected. Over the time, what styles are common goes over the time. I took a quick look on Google, and I noticed a couple of interesting stuff there. The monolith architecture, it's still present, and microservice and serverless architecture, it's started to popping up. Microservice, I was kind of expected that. Serverless, it seems like it's gaining more and more traction. But the interesting part here is that the monolith part, it's kind of keeping steady, and it's very, very close with the microservice application. And the decision besides this can be multiple. One of those can be the cost part, because sometimes it's more efficient to architect to using a monolith architecture to create a platform. Of course, doing in microservice serverless can be very appealing for your developers, but the cost of infrastructure and dealing with all the complexity behind this, in some cases, it's not efficient. I notice also a shift in paradigm here. So it's appeared that more and more platform that appears on the market, especially in the SaaS cloud environments, are moving and are evolving to being using microservice with different flavor, even hosted on Kubernetes cluster, or even of new technology like Fargate and serverless. But also more and more platform are started to offer new way of connectivity that didn't happen in the past. And what I mean with this, it's having full RESTful APIs or other type of APIs connectivity to allow different party application and to different customers to connect with. And the most successful one are those that are built having with the developer centricity mindset. And the best example, I think, it's Stripe. They started to build the platform thinking on the developers who will actually do the implementation, and it's a huge success. Where the trend is going, I think the trend is going to build platform in a more autonomous way. And when I say machine to machine, I not mean two systems connected together or connectivity between system. I thinking about platform that can leverage some sort of artificial intelligence and machine learning to auto connect with different part of environment available in that particular company, or to different vendors and business partners. To sustain this, it's a new buzz with also with autonomous APIs that actually doing the kind of the same thing, auto connect with and find the best API to fulfill the business requirement. Going back to the next generation platform architecture, like I said, it's very important to have the best setup in mind and tailor your architecture, your platform architecture based on the condition that are in the market and based on your company. And same way with the architecture style, you'll in most of the cases, you don't use the same style that is applicable to another company, and because your conditions are different, and your development team are different, your infrastructure department are different, and so on. And when you talk with when you think on architecture style, it's and when you build that, it's using the set of constraint and property that apply to your company. In terms of constraint, those can be kind of listed in deep multiple way, but can be tailored on also on the business requirements or the business constraint, and there are those constraints are coming from whoever will finance your platform. Those are coming from the product requirements. Those are usually taken from the cost estimation that you have and from the budget, and are aligned with the company strategy and also with what your customer wants, because the whole scope of building platform is to solve a problem that your customer having, and when you solve that problem, you need to make sure that that will be very efficient and very straightforward for the end user. Another type of constraint when you thinking on architecture style for your platform, it's the domain one, and that and when I thinking of domain constraint, I think about different types of governance and regulation that are in place. So, for example, you need to build something for European Union. You need to apply the GDPR regulation that are in place. You need to build something from banking for banking sector. So you will need to follow the banking regulation, and so on. And in some cases, you perhaps build a platform in a domain that has some specific limitation tailored to that domain. And one example in mind, it's the security sector. And those there are different type of regulation and limitation when it comes in mind, when it comes in with architecting a new platform for them. One of the most important parts that it's kind of forgotten by whoever start to architect platform is the cultural constraint. You need to understand very well what is your team strength, also what is your human resource plan in terms of acquire new resource, and what kind of leadership support you have, because you may end up in the situation when you want to architect a platform with all new cool technology and using perhaps Kubernetes, Jaeger, and so on. But your leadership see the problem a little bit different, and then you'll end up in the situation when we need to choose another technology stack. Another thing that is very, very important and need to take in consideration is the knowledge that it's inside the organization, and also the trends in that specific domain market. Complexity, it's also one of the constraints when you build platforms. You need to think about the size of the platform, the size of the functionality that you want to add, how you will split that size in different cycles, and also things that are unpredictable, like traffic flow, estimated users, and so on. But those can differ for one case to another based on what exactly your platform want to do. And something that started to come more and more in the picture are the environmental constraints. More and more companies are started to look, when they build a piece of software, to be very energy efficient from different reasons. One is to protect and become more greener companies, and the other one is the cost reduction that comes with this building a platform with energy efficient in mind. There are another things like external constraints or social requirements that may be put in the picture when you define your architecture style. And yeah, to summarize, the constraint, there are split in five. I split it in five domains: business, cultural, complexity, and environment. And like I said, not all of them are applicable for anyone that wants to build a new platform. Some of them may be applicable. So for example, one company may have some cultural constraints and some business constraints, and another may end up only having some complexity constraints and so on. And those will be added and taken in consideration when you'll have a final review of your architecture style. Another thing that it's very important when you start to build and architect platforms are the properties that you want to put it in place when you build a new piece of software. And some of them I mentioned here can be related to cost, performance, what you want to be your scalability of your application, how simple you want to make, and how portable you want to make. Because another discussion that most likely to happen will be where to put this platform. Should this new platform be put it on-prem, or should be cloud agnostic, or should I cloud native? Sorry, or should I use multi-cloud approach to tailor different business needs in a multi-cloud environment? There are some considerations that also need to be taken in consideration. I already mentioned the cloud agnostic and cloud native part, but you need to take in consideration what tooling you want to use when you build a new platform. Things like maturity, and when I think of maturity, is maturity of my team, and also maturity. What is the maturity of what is the expected maturity of the product that I want to build? And one important thing, it's related to community, related to the platform itself, and community related to the company, or community related to open source technology, or specific to a vendor. Another thing that need to take in consideration, it's how easy you want to deploy your application, and how accessible you want to have your application. And when I think on how accessible I want to develop and build my platform, I'm thinking on how many or what type of connectivity I want to offer to my platform. Just to iterate what I said a couple of times till now, every platform needs different properties, and every platform will have a different type of architecture style that will be tailored on a combination of factors. It's a receipt that I kind of draw it. So every time when I thinking on a platform architecture style, I thinking on a combination between the property, the architecture property, the consideration, and also the constraints based on my organization. And those three will define the architecture style that I want to use for that platform. One of the example based on what I highlighted earlier. So, for example, based on what I want to do and based on my company, I may end up taking in consideration when I choose my architecture style, the cost, the performance, scalability. Also, I take the tools. My platform need to be cloud agnostic, and I will use open source technology to do that. And this is just one of the example. Another platform may end up in using another combination of property and constraints to build the architecture style. And yeah, the last takeaway, it's that you always need to decide when you build your architecture style based on the constraints and your consideration. And I just to reiterate that you are unique as a developer and architect. And if you, for example, if you put two architects or two developers to build the same piece of functionality, more or less they will build using a different approach, but the final product will fulfill the same requirements. That's it. Thank you very much. And let's look on chat to see if there are any questions.
Thank you, Andrei. Really appreciate it. The only question that someone had was what was P&C on one of your earlier slides, and someone suggested producer and consumer.
Exactly, yes.
So, great. Perfect. So we are pretty much out of time. So I'd like to thank all of our 3 speakers tonight, and to our sponsors and to everyone else who joined this evening. I really appreciate you coming and persevering with our first virtual event. And yeah, we'll be back again in the first Wednesday of May. Thank you so much. Have a good rest of your evening.
Thank you, Cheryl.
Thank you, Cheryl. Thanks, everybody. Bye-bye.
Cheers. Bye.
Thanks, everyone.